Let us solve this problem. A farmer is placing posts at points A, B, and C in the ground to mark the boundaries of a triangular piece of land on his property. From point A, he walks to B, 230 meters due west. So from A to B, that's 230 meters. From point B, he walks 175 meters on bearing of 63 degrees to reach point C. This is shown in the diagram below, although this diagram is not drawn to scale. The farmer wants to divide a piece of land into two sections. He will put a post at point D, which is between, so D is between C and D, A and C. He wants the boundary BD, so if you're going to draw a line here, going to D, he wants BD to divide a piece of land such that the sections, these two sections, section A, or section 1, and section 2, have equal area. This is shown in the diagram on the next slide. This diagram represents how the farmer wanted his piece of land to be divided. Now there are questions here like we need to find the distance from A to point C. So we would like, this is question A. And then next we want to find the area of this piece of land. So this piece of land is the whole thing here. That's going to be your answer in B, area. And then for letter C, we would like to find the angle CAB. So we would like to find this. Okay, that will be for problem letter C. And then lastly, we would like to find the distance from point B to D, which is represented by this. Okay, so let's try to solve one by one. Let's try to solve each of this problem in the following slide. We would like to solve the distance from point A to C. So we can use cosine rule. By the way, there are two rules for cosine. We can have if we're looking for the distance, we can have c squared equals a squared plus b squared minus 2ab cosine c. Or if we're looking for the angle, we can have cosine a equals b squared plus c squared minus a squared over 2bc. So this is also in your formula booklet. The thing here is when we use cosine rule, we use cosine rule when two adjacent sides are given. And this cosine c, this angle is the included angle. Okay, so these are the adjacent sides. These two are adjacent sides, and this is the included angle. Now, angle B is not given in the problem, but we know that there is a degree here, which is 63 degrees. So we can say that our angle CBA is equal to 90 degrees minus 63 degrees. So this is equal to 27 degrees. So let me just erase this part. Okay. So we know that angle B is 27 degrees. So to find CB, we can use CA. So our CA, actually that's CA squared, equals the adjacent sides, which is 175 squared plus 230 squared minus 2 times the two adjacent sides, 175 and 230 cosine 27 degrees. One thing that you must take note of is make sure your calculator has the proper setting and the mode is in degrees. So you do that first before you encode this data. Now, you will be having an answer here. So you can get the square root because we are only after CA. So when we get the square root of this, we also get the square root of this. So you can already encode this as square root of this expression. So we shall have CA equals, use your calculator, you will have an answer which is 108.62308. Always write this as the first answer. So your CA or segment CA or AC, I think we're looking for the distance between point AC, so it's either AC or CA, is 109 meters. Make sure you also save this because you may be using this later on. Please save this. You use control var and assign a variable for this. Okay, let's solve the next problem. For this problem, we would like to find the area of this piece of land. So we will just be using the formula for area of triangle, which is 1/2 AB sine C. So again, this refers to the adjacent sides, and this is the included angle. So we know this to be 27 degrees. Again, make sure that the mode of your calculator is set to 22 degrees. Okay, but when you encode it, you don't have to put the degree symbol. So we will have the area equals 1/2 of 175 times 230 times sine 27 degrees. So again, you don't encode this part in the calculator. You just write sine 27 because it's already in degree mode. Now the area will be equal to 9136.55 square meters. It's actually, there are still many points here, so you can use these marks. But then the final answer shall be written as 3 sig fig, so 9140. So there are 4 digits there, square meters. So this is the area of this triangle. Let's solve letter C. In letter C, we will find angle CAB. So this is what we're looking for. The question is, what rule shall we use? Can we do cosine rule or cosine law? Looking for angle A. So let's say cosine A. Do we have adjacent sides and included angle? So we have, because this is already solved, and this. So by the way, let's call this our side B, which is 108 point something. How much is that? 108.62308, the original. And this is our C, and this is our A. So we can apply the rule that cosine A is equal to adjacent sides B squared, the sum of the adjacent sides, B squared and C squared minus the opposite side of the unknown angle, which is A squared, over 2 times the product of the adjacent sides. So we can use cosine A. Okay, so if we're going to solve for cosine A, so to find A would mean to get the arc cos of this B squared, which is, if you store this, so it's going to be 108.6 squared. Okay, this is continued, plus the c squared 230 squared minus the square of the opposite side 175 squared over, you're getting whatever is the answer here, you're getting the arc cos of that over 2 times the b here is what you saved a while ago, so 108.62 dot squared, and no, it's not squared, sorry. So it's just 2 times the two times the adjacent sides. So adjacent sides are b and c, so it's 230. Now this will give you an angle A, which is equal to, how much is that? 47.0049822, and it goes on and on, but we need only to answer up to 3 significant digits. So yeah, 47.0 degrees. Now, can we solve using sine law? Yes, we can do that using sine law. Under sine law, the sine of A over its opposite side is equal to, so what can we use? Can we use angle B or angle C? So we can use C also, but then we need to solve for C first. But B is already given, so we can make use of sine of B. So sine B over the given B, it's solved already from the previous problem. So we can look for sine A because we're looking for angle A. So we do sine A is A sine B over B. Or we can say that A is equal to arc sine of A sine B over B. Okay, let me continue here. So our A equals arc sine. So again, make sure it's in degree mode. Arc sine of what? Our RA is 175 and we have sine 27 degrees over B, which is 108.623 dot. So we will have an answer which is 47.0049, and that's also equal to 47.0 degrees. So whichever this is C, by the way, you're looking for CAB, so we write our final answer as CAB. So this is the symbol for angle, CAB equals 47.0 degrees. So we have shown here that we can use sine rule and cosine rule in finding the angle for CAB. In the last problem, we need to find the distance from B to D. Let me have this B to D. This one, okay? Sorry. So B to D. Now, we will be asking ourselves, so by the way, these are the given. We already know this is given 47 degrees. And this is 23 degrees, the whole thing. This is opposite of A. This is opposite of C. And this is opposite of B. Okay, we already solved for this one. 109 is the rounded off answer. So there's no word hence. That means we're going to use the original values. Now the question is, to find BD, can we use sine rule? So for sine rule, that will be, we have this opposite each other. But then we don't know this angle. We know that that segment divides CD, but it doesn't tell that it's a bisector of the angle. So we cannot use sine rule here. Instead, we will be using cosine rule. So Under cosine rule, again, under cosine rule, so you need to have adjacent sides and included angle. And this included angle has the opposite side. Usually that's the missing. So in this case, if we're looking for BD, which is the opposite of A, then it looks like this. These are the adjacent sides. So your figure look like this. And then we're looking for this part. So these are the adjacent sides, adjacent beside each other, and this is the included angle, which we know to be 47. So we know this to be 230, and this is 47.0 degrees. Did we save it? So we must have saved also the value of this, so we can use the original value. So, and then, but this is not given, no? So if this is not given, is there a way we can find it? Yes, there is a way, because from the problem it says that D is the midpoint. So if you divide B, so this part shall be whatever is your answer in B divided by 2. In that case, 108.62 blah 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 divided by 2. So we can now find our BD using the cosine rule for the sides. So BD is equal to, it's actually BD squared, so we're getting the square root of that. So we will have the adjacent sides, which are 230 squared plus our AD here. This is our AD, half of your 108.62 dot. So divided by 2, it's half. You square it, minus 2 times the adjacent sides, 230, and half of it, AD is half of, AD is half of AC or CA. So we go to AD, which is 108.62. So this is already stored over 2. And let's continue. Cosine A. This is also stored 40.00 something. Okay. 47, sorry, 100 something. This must be also stored. So we will be using values which are original. So we'll have our BD equal to 197.009. So why are we using original values? Because it will lessen the degree of error in the solution. Okay, so we will have 197 meters. So this is distance BD. Final answer. Okay, please subscribe to be updated on the next problem. Goodbye, everyone.